Okay, so I'm recording this session para sa mga hindi makakapasok today, no? Right, so let's start. And again, ang session na to will be a walkthrough dun sa ano natin, no? A worksheet for deformation processing, specifically rolling, no? Okay, so I think we can go straight ahead with the first problem na. Okay, so this is our first problem. Meron daw tayong 60 millimeter slab and which has a width of 600 millimeters. At tapos it is to be rolled to produce a 35 millimeter thick sheet. Tapos the roll diameter is 800 millimeters. Knowing this, knowing that the average flow stress is 155 megapascals, we are to determine the number one, yung lubricant oil that must be used to produce the required specification using unaided entry. So ito yung isa sa keyword na yun, no? Unaided entry in a single pass. And ano yung magiging average rolling load of the operation using that lubricant, no? Okay? So first, when we handle this sort of problems, no, kailangan muna natin visualize siya. So we have a roll, and two rolls dito. Tapos may papasok na slab that is 60 millimeters, no? Tapos pag lumabas siya dito, it now measures 35 millimeters. Okay? Now, wala namang sinabi about elastic rebound, no? So, we can assume na yung...
Sir,
Yes?
hindi po kita yung screen.
Hindi kita yung screen.
Ay, nag-share po ba kayo?
Ay, sorry. Hindi pa pala kita yung screen ko. Ano yung nakikita? Wala lang.
Opo, yung kanina po, sir. Yung pinaka. Ayun po.
Ayan. Kita na.
Opo,
Sorry,
sir.
sorry. Thank you, Lawrence, no? Sorry. Na-stop ko pala yung OBS ko. So, yun. Ulitin lang natin, no? So, again, the first part to solving this problem is always to visualize kung ano yung nangyayari sa ano natin, no? Workpiece. So, we start with a 60 millimeter slab. So, this is the entry. Tapos exit, magiging 35 millimeter siya. Okay? So, meron tayong two rolls and each of the rolls has a roll diameter of 800. So, 800 millimeters ito. Okay? Millimeters. Now, again, as I was saying earlier, no, hindi kasi indicated na merong elastic rebound na kailangan i-take into account. So, we could assume na yung ano natin, draft natin is kumbaga the draft can be equal to the ano no yung parang amount of reduction dito. So whatever is the difference between the initial and the final heights could be the maximum reduction natin. Okay? So if you were to aim for maximum reduction, yung H max natin kasi has the formula delta H max is equal to mu squared r. Tama? So, this is from the modules, no? And you can look into the derivation kung paano siya nakuha. Pero, the maximum na delta H na kaya natin gawin sa isang system is this one. Delta H max is equal to mu squared per r. Right? So, if you want to find mu, so, kasi kailangan natin ma-determine si mu, no? So that we can solve for or we can choose the appropriate lubricant. And therefore, pwede natin i-rearrange, no? So we can go mu is equal to, paano ba to? Mu is equal to delta H max over roll diameter R. And we get the square root of this entire thing, no? Okay. Right? So ito, delta H max, what is our delta H max? So again, we assume na walang elastic rebound, no? So therefore, our delta H max will just be yung initial, which is 60 millimeters minus 35. Okay? So parang ganyan siya. So if there was elastic rebound, so kunwari kung nagre-rebound to, so definitely itong 35 will be 35 plus something pa, no? So yun yung ano niya. So which means that you need to take that into account, no, when we're solving these types of problems. Pero again, dito wala namang mention about elastic rebound. So therefore, we can just assume na yung 35, yun din yung gap dito, yung 35 na to. Okay? So, with that, delta H max is equal to, or mu is equal to delta H, square root of delta H max over R. And since gusto natin isang pass lang siya, then we assume na yung maximum, yung delta H natin maximum will be yung gap na gusto natin ma-achieve, no, in the first place. Okay, so that's why 60 minus 35 lang siya. And we can solve this, no? And hindi ko na ipapakita yung final answer. I'll leave that to you para uh, yun yung isusulat nyo sa worksheet nyo. Dito si R is also given, no? This is the roll radius, and usually siguro ano na rin to, no, word of or caution na rin to. Usually kasi ang given when we are given values for rolling parameters, no, usually ang binibigay talaga is the diameter. So you need to take that into account kung i-divide nyo by 2 or use the actual value itself, no, when you plug it in the equation. Pagka walang binigay, kunwari ang sinabi lang it's an 800 millimeter roll, the convention is you are talking about the diameter, no? So whenever you talk about rolls tapos value lang binigay tapos hindi binanggit kung diameter ba yun or not, then you can assume na diameter yung binigay niya. Okay? So and in fact sa board exams lumalabas siya minsan, no. I remember in our board exams parang binigay is parang something like 500 millimeter roll daw ang operation tapos hindi sinabi kung diameter ba yun or radius, no. So um marami ata kaming nagkamali doon. Pero again, you always assume na they're talking about diameters pag ganun, no? Okay? So, saan ba tayo? So, ato, masasolve na natin yung mu. And since masasolve na natin ang mu, kaya na natin pumili ng appropriate lubricant, no? So, you just choose which of the lubricants fall under the mu na target natin dito. Right? So, okay na tayo sa letter A. Now, sa letter B naman, the average rolling load of the operation, i-compute naman natin. So, if you look at the, ano, if you look at the formula for forging load, no, it's actually quite similar to, or sorry, rolling load. It's actually quite similar to the forging load calculations, no? So, di ba, let's look back at the forging, ano, no, forging load. So, I'll just say F sub F. So, you have your Y or your flow stress, and let's call it Y prime, no? So, Y prime. So, kayo na bala kung i-apply nyo yung plane strain correction factor or not, no? So, Y prime multiplied by, it's Y prime multiplied by 1 plus mu A over 2H. Tama? This is our formula for forging load. And I'm not sure if F yung ginagamit natin na term, no? Tama naman siguro. F. Or do we do P? Let me go back, no? Kasi para ano tayo, consistent tayo sa convention natin. Did we use F or P? Sa atin ito. Okay. Forging. Where is forging? Mm, what convention was used? Uh, tingnan lang natin ah. Sigma. Ayan, F din pala yung ginamit niya. So, if you look at this, ito yung equation niya, no? So, it's mu. Wait, saan yan? Where is the final form? Ito. So, we have the average, no? Na forge. This is still the stress, no? So, if you multiply this by the area, then you get the forging pressure. Okay? Or the average forging load, I mean. So, this is forging pressure. And multiply it by area. And in this case, yung area kasi natin is byte times the width, no? Byte times width. Byte times width, tama. So it's byte times width. And if you do that, then you get the average forging load, no? Right? So etong A na to, this is just byte over 2. Okay? So balikan natin. So balik tayo dun sa ano, no? Sorry. So this is supposed to be B. Tama. Kasi pinalitan ko na yung uh, forging, ano, no? So it's mu B over 2. So pwede rin mu A over H, no? Pero let's use byte dito para ma-compare ko sa analogous case of on the rolling side naman, no? And we multiply this by so if you remember forging load, so if this is your workpiece, tapos it has a width na sorry, W, tapos ito yung ano natin, dito yung forging tool natin, and it's moving downwards. Then ito, itong part na to, this is the byte, no? Okay? Tapos yung width na yan is, and depending if the width is constant or not, yun yung i-apply nyo yung ano, yung correction factor, no? Yung 2 over square root of 3 or yung 1.155, no? Tama ba? 1.155 nga ba yan? So let's do a quick calculation. S- Square root of 3. Wait. Kita ba yung calculator? Ayan. Kita naman. So let's do
Kita.
2. Thank you for the feedback. 2 over square root of 3 is 1.155. Tama naman. So yan. So hopefully you still remember this from forging, no? Pag again, kung plane strain siya, plane strain meaning that the width is constant. Then we use a correction factor na 1.155, and the derivation can be seen in the ano, no, in the, I think nasa forging lecture yung derivation ito. Okay, so it's 1.155. Tapos pagka hindi naman siya plane strain, and the opposite of plane strain is yung homogeneous deformation, no? Pag homogeneous deformation siya, hindi tayo maglalagay ng itong correction factor na to. Okay? So, we have y prime is times 1 plus mu b over 2h multiplied by width multiplied by byte. So, ito yung equation sa forging load, no? And actually, yung si rolling load uh, is analogous to this one, no? Because basically, they are doing the same thing. It's just that naka-curve yung byte actually niya, no? So, ito yung byte niya. Dito yung part. So this is I forgot the term. I think it's rolling byte, no? So ito siya. Ito yung byte niya, and this is where the compressive forces occur, no? So if you can imagine the compressive forces, dito siya nag-a-apply, which is similar sa compressive forces na na-apply dito sa ano natin. And the width is obviously yung dimension na papasok sa board, no? So width. In ano kasi in rolling, um because we are dealing with yung aspect ratios niya is such that yung width niya is so much greater than the height. Usually or yung width niya is so much greater than the height, I mean. Usually for rolling operations, it's always assumed na plane straight siya, no? So parating lalabas ng factor na to. So let's just input the factor, no? So si rolling will have 2 over square root of 3 multiplied, unless of course it's mentioned, no, na parang sabi homogeneous deformation siya. Pero kung walang mention at all, then you can assume na plane strain siya. If you want to be sure, there is also a I don't know a formula that you can use. And for rolling, kasi 'di ba sa forging it's width over byte, if width over byte is greater than 3, tama ba? Pero sa rolling, let me check my notes, no? Kung ano yung condition for plane strain. It's width over byte greater than or equal to 5 naman sa rolling. Okay? Yun yung plane strain condition natin. Alright? So, just review your notes para mahanap nyo to. Pero again, in most cases, plane strain si rolling. Right? So, nandito tayo. So, it's 2 times square root of 3 over y times etong mu over b na to, yung b ni rolling is, 'di ba sa forging, it's this dimension right here, no? Ito. But in rolling, it's a curved path, no? Tama. Ito siya. Yun nandito. But we can estimate this curved path and nasa notes na yung derivation, no? Pero the curved path can actually be estimated as square root of r delta h. Okay? And this square root of r times delta h. This is the byte that we will be using when we do calculation sa ano no sa rolling. So what we actually just do here is replace lang natin yung lahat ng b with the square root of r delta h term. So we get 1 plus mu is still mu, no? Tapos multiplied by r delta h over 2. Now, the height here, in if you look at ano no, si forging, the height is consistent, no? Tama? It's a constant value. So as you move downwards, this height o kumbaga the overall height will always be the same, no? Assuming that the tool is moving parallel or perpendicular to the um to the area of the tool, no? Itong dalawang die na to. So if it's moving constantly downwards, then mangyayari itong height na to will always remain the same, no? Whether you measure it from this end or you measure it from this end, it's always the same yung height natin. Pero si forging kasi, if you look at forging, and let me zoom in a bit, no? If you look at forging, oh, you'll notice na you begin with this height, and as you go through the compression process, ang nangyayari is the height is actually not constant, no? Nagde-decrease siya as it moves through the rolling operation or uh the two rolls. Okay? So that means that etong h value na to, hindi natin pwedeng i-input lang one value of h, no? So kasi hindi natin sure kung ano ba i-input natin itong initial or yung final. So what ends up happening is you get the average height, yung kinukuha natin. And to get the average height, you just take the initial uh and the final and you divide it by 2. Okay? So you get the forging na na forging operation or the forging equation that looks like this. And bakit magkaiba to? Magkaiba pala yung kulay na to. Okay. Now you can replace this term with, instead of using ano no, this one h naught plus hf over 2, pwede actually ang gamitin nyo is yung uh and it will be the same, no? Instead of using this one, you take h naught minus delta h over 2. Okay, that will give you the same value, no, as this one. Okay, and we can show it. Delta h is equal to uh if you look at the top, delta h is equal to initial final minus initial, right? Tapos ang if we replace na HF, ano, if we replace, tama, if we replace HF with delta H, so this becomes delta H is equal to, and ilalagay natin on the opposite side, so magiging HF, sorry, balik na rin natin. So HF is equal to H delta H minus H naught. Tama? So, kung ililipat natin yan doon sa original equation natin, we get H naught plus, parang baliktad. H naught plus delta H minus H naught. Pagka-cancel. Dapat plus to. It's minus. Wait lang na there might be something wrong. H final minus H initial. Hmm, may mali ba sa pag-transpose ko?
Mas malaki po yata lagi dapat yung H initial, sir. So,
Ay, oo, tama. Sorry. Thank you for the correction, no? Kasi this is a reduction operation, no? So, kaya, thank you, Lawrence, no? So, this was supposed to be baliktad siya. Okay, that makes a lot more sense, no? So, this is H naught minus HF if we want to get the, ano, no? A positive value sa delta H natin. So, we get, this now becomes negative H naught minus delta H na siya. So, if we input that, this is now plus na to. Kasi ito yung minus, no? Minus delta H. So, this becomes 2. Sorry. Wala to. So, this becomes 2 H naught minus delta H over 2. The 2 cancels out and you end up with this equation right here. Okay? So, it's up to you whether you want to use this form or this form. Pero dun sa modules, I think the final form is shown as ano no, H naught minus delta H over 2. Okay? Tapos, yung width natin is still the same width, no? Width pa rin siya. Yung byte, again, replace natin with this term right here. So, we get R delta H. Okay? Now, for this problem, given naman ang flow stress, so we can input the flow stress here. Tapos, we know the width. The width is also given here. Sabi niya width of 600. So you can input the width. Tapos, R is also given. This is given. This is given. Width is given. And delta H is also given, no? Ito yung na-solve natin kanina, which is this one. So, kasi we are assuming that it is a single pass. So, delta H is also given. And wala na tayong other unknowns, no? Yung U, na-compute na natin siya. Ito, dito. So, we can solve for the forging, the rolling load, I mean. So, kaya na siyang ma-solve siya. Right? So, that is number 1. Fairly straightforward lang. Let's go for problem 2 naman. Okay? So, dito sa problem 2, meron na tayong 4 millimeter thick sheet having a width of 750 millimeters, and it is to be produced using the following considerations. No? So, number 1 is 30 millimeter thick plate. You need to produce a 30 millimeter thick plate having a width of 750. So, clue na agad to, no? You started with 750. No, sorry. You started with a 750 millimeter thick plate. Tapos, ang ipoproduce mo is, again, a 750 millimeter thick sheet. So, ang thickness lang nagbago, pero yung width hindi nagbago. So, therefore, plain strain to. Plain strain. This is plain strain conditions na siya. Kahit hindi nyo pa i-compute yung, no, width over byte, you already know na plain strain condition to. So, is to be hot rolled to a thickness of 8 millimeters. Okay? So, ito yung initial pass. So, sa initial pass, plain strain. Tapos, next is the product in A is to be cold rolled to a final thickness of 4 millimeters. Okay? So, ito sa second pass, since 750 to dito, so if you can imagine, this is a case wherein you have a continuous na rolling mill, no? Wherein you have multiple passes. So the first pass, you can imagine na yung first pass natin, this was the rolling mill. So this is pass 1. So yung exit na feed ng, or yung exit product ni pass 1 will be the entry feed for pass 2. Okay? So si pass 2, pasok siya na ganyan. So this is pass 1 and we have pass 2. Now, in both cases, no, plain strain siya because you started with 750. So this was 30 millimeters dito. Then you ended with 8 millimeters sa first na hot rolling pass. Tapos sa second rolling pass, 750 millimeter width pa rin siya, but now it's 4 millimeter thickness, which is the final thickness that we are aiming for. Therefore, in both conditions, plain strain siya. Okay? Then, feeding of the material to the entry of the gap is unaided. So, unaided ulit to. So, we can use the equation delta H max is equal to mu squared R. Tapos, again, elastic rebound is neglected. So, we can assume na yung 8 millimeter na final product will, or yung gap dito na 8 millimeter is also the final product na thickness niya, no? So dito, this one right here, yung 4 millimeter gap na to will also be the 4 millimeter thickness, no? Okay? And we want to use the minimum number of stands available, no? Okay? So this is important because for these types of operations, no, kailangan kasing tingnan natin if, or ang gusto natin is we compute for yung maximum muna na amount of deformation na uh, kayang i-achieve ng isang rolling mill system without the aid of an external na feeder, no? So meaning unaided yung entry niya. Okay? So, just to recap, no, and probably you've learned this from the modules itself. Kaya siya, yung term na unaided entry comes from, kasi when we have a roll that is passing through, you'll notice na this is a compressive force, no? So it will be friction that will force the metal inside. So friction, papasok, kasi this is rotating this way and this is rotating this way, no? So it will be friction that will make the material go inside, going through the pass. Pero you'll notice na itong compressive forces natin that will deform the metal actually has a parang reactive na na forces, no? So parang reactive forces siya going in the opposite direction naman of the entry. Tama? So ito kasi naka-angle siya ng ganyan, no? So meaning meron siyang component na going on the left side. So doon nanggaling yung reactive forces. So for you to have unaided entry, dapat yung frictional forces that are going to the right side, in this case the right side, no, the frictional forces that are going on the right side should be greater than or equal to the reactive forces that are going to the left side, no. Okay? So doon nakuha actually yung mu squared, yung delta H max equals mu squared R, no? So that is um from the from balancing the forces na involved in it. Okay? And you are assuming na unaided entry siya. Right? So, let's try to solve this, no? Ito yung mga working parameters natin. Yung hot working condition is 500 yung millimeter roll diameter na gagamitin. Pero for the final um yung cold working, and by the way, yung pagka final siya, we use the term planishing, yung tawag nila, no? A planishing roll. The planishing roll is where you use cold rolling tapos fairly smooth yung rolls na ginagamit natin such that yung natin product natin will have the final na parang roughness na na gusto natin ma-achieve, no? And in rolling usually yung planishing roll natin or planishing die will give you the smoothness na gusto natin. And sa rolling naman, this is fairly achievable without na, no. Kung ano yung kalalabasan doon sa planishing roll, hindi na siya actually kailangan i-post-process pa. Right? So in this particular case, parang yung final roll natin will be the planishing roll, no. And that will produce the final thickness of 4 millimeters and also the desired na surface finish, no. Right? So just a recap na lang din sa concepts that we've learned so far. Yung hot rolling again is usually used for cases wherein you want to achieve large amounts of deformation, no? Okay? Ang issue lang sa hot working is that na parang hindi maganda yung finish, no, because you're working at conditions or higher temperature conditions, and therefore kung higher temperature conditions siya, mas may tendency mag-oxidize yung workpiece natin. Okay? As opposed to yung cold rolling conditions, wherein sa cold rolling conditions, you're working at fairly lower temperatures and therefore mas maganda yung surface finish na achieve mo. Ang problema naman sa cold working conditions is that because the material is being strain hardened, so you are compressing the material, you are deforming it, and therefore nag-undergo siya ng strain hardening. You can't achieve that much of a deformation because again, kung if you pipilitin mo talaga, ang nangyayari is the material might fracture, no. All right. So with that said, hot working initial, usually ginagamit siya sa initial because malaki yung deformation na kaya. Cold working pang final finishing siya. All right. So and probably you already know bakit siya kaya niya ma-achieve yung high amounts of deformation. Kaya niya ma-achieve yun kasi when you're doing hot working conditions, yung temperature mo is at a condition wherein favorable yung recrystallization, no, and grain growth. So ang nangyayari is yung strain hardening that is occurring while you are deforming your material is offset by the softening na nangyayari dahil sa elevated temperature. So kaya that's why hot working it can be used to achieve large amounts of deformation. Okay? So let's go back to the problem. Meron tayong given a working parameters, no? 500 sa hot, 300 for the cold working, and meron tayong coefficient of friction na binigay for Hot working, it's 0.5 yung gagamitin. Cold working, it's 0.15. Tapos, meron tayong mga roll speeds din. Hot working operates at a lower roll speed, no? And this is measured in RPM, so that's revolutions per minute. Revolutions per minute is 40. Tapos dito naman sa cold working, it's 65. It's a lot faster, no? 65. Okay? So the material flows test during the hot working condition is 200. Tapos on the other hand naman, si cold working condition will vary with strain following the Holloman equation. So kailangan pa natin i-solve siya, no? Etong cold working condition na strains. Okay? So, note that the material yield strength is at 300 megapascals in the annealed state. So, this is after the hot working. So, annealed state meaning after sa hot working na pass, no? So, ito yung gagamitin natin pagka gusto na natin makuha itong sa cold working conditions. But before that, determine muna natin yung hot rolling muna, no? Okay? So, again, kasi ang condition is stating dapat minimum number of stands to be used, no? So again, these passes are also known as stands, no? So one pair of roll, or if it's multiple, depending on the design ako, kasi pwede naman siyang and you learn this in the module, no? May mga concepts doon. Yung different types of rolling configurations. Pero one pass is also known as a stand, no? So we call this as a stand. And depending on what is your configuration, pwede magbago yung number of rolls, no? Pero yung mismong we call this as the work rolls, no? So this is the work roll. So yung work rolls natin, for each stand there should be at least a pair of work rolls, no? Etong nasa taas yung nagsusupport, actually by the name itself, no, yung function niya is to support. Ang tawag actually dito is support rolls, no. So there are multiple configurations para dito. You have 2 high stands, you have 4 high stands. Tapos meron din kayong mga reversing rolling mills, and meron din yung 3 high, no, which is parang yung kung parang maglo-loop backward siya. So yun. So hindi na siya masyadong importante for this problem, no? But what is important is that we want the we want the minimum number of stands. So kung kaya siya ng isang pass lang, i-design natin siya na isang pass lang. So yun yung first natin i-compute, no? Can we do the hot rolling? So we do hot rolling muna, no? So we do this so our calculations will be in 2 stages, no? First is let's compute for hot rolling conditions muna, then we compute for the cold rolling conditions. Okay? So sa hot rolling condition, can we do it in one pass? Okay? So what we do is we compute for delta H max is equal to, and we'll use this equation again, no? We'll do mu squared over times R. Okay? Okay, so again, ang binigay naman yung rolling diameter, no? So if you divide that by 2, we get the roll radius, no? And if we compute for that, we'll now know if single pass siya or kung kaya ba siya ng single pass or not. Okay? So the way we determine that is compute natin siya, delta H max. So kunwari ang delta H max dito lumabas is, let's just say 50 kunwari, no? 50. So 50 is, and this is not the actual value actually, no? So you need to compute it on your own. So if 50 is greater than the initial pass na requirement natin, so for this case, gusto kasi natin 30 and we need to bring it down to 8 millimeters. So delta H in this case will be um 30 minus 8, tama? That is the amount of reduction na kailangan natin gawin. And we call this as a draft, no? This is the draft. So the draft, in this case, draft nga ba or gauge? Wait lang, let me review the terms. I know it's the draft. but I could be wrong. Baka gauge pala siya. Okay, draft naman. So, the draft is the reduction. So, if this is your, let me illustrate again. No? So, ito siya. This is two rows. Pagka pumasok siya ng ganyan, the draft is this one right here. So, if we like that, this is delta H over 2, tas dito rin delta H over 2. So, if you add the two reductions on both sides, and we are assuming na symmetrical sila, no? Delta H over 2, delta H over 2, that will be our total draft. Tapos, ito naman, itong gitna, itong gap na to, we call this as the gap or gauge. Okay? So, yun yung some terms na ginagamit to. Okay? So, so our draft for this case, yung first hot rolling operation no, is 22 millimeters. And let's just say 50 yung nakuha natin. No? If 50 yung nakuha natin na delta H max, that is greater than 22 millimeters. And therefore, kaya natin gawin yung one pass lang. So if kunwari yung nakuha natin is 20 millimeters, then in that case, 20 millimeters now is lower than 22 millimeters. Therefore, hindi kaya na isang pass lang. Kailangan two passes or two stands yung gagawin natin for the rolling operation. Okay? So, I leave it to you to compute kung kaya nga ba isa lang or dalawa yung kailangan or tatlo even. Um, and you can solve that using delta H max. Alright? So, let's just assume na, ano no, isang for the purpose of this discussion, no, let's assume na yung na-compute natin is yung value na nakuha natin is greater than the 22 millimeter requirement. So therefore, one pass lang yung gagawin natin. And kung one pass lang yung gagawin natin, we can now compute for the hot rolling load. No? So again, yung rolling load naman natin is just equal to, again, it's plane strain because again, hindi nagbago yung 750 millimeter width. So we go 2 square root of 3 multiplied by the width, which is equal to, I don't know, ano ba yung width natin? Width is 750 pala, sorry. 750 multiplied by the byte. The byte is equal to, oh no, sorry. Before that, 2 times square root of 3 times y muna. Tama? Yung y naman is given, no? And y was, sabi daw sa hot rolling condition is 200. Again, 200. Multiply this by the width, which is 750. Multiply it by the byte. Again, the byte for um, rolling operations is square root of r delta h. So that's square root of roll. For hot rolling, it's 500 and therefore 250. Gagamitin natin 250 multiplied by delta h is 22. No? Okay? Tapos, we multiply this by 1 plus yung mu byte, which is r delta h over 2 multiplied by, you can do h naught plus h final all over 2, or you can do h naught minus delta h over 2. Okay? It will give you the same value, no? Again, given naman to, h naught is 30, delta h natin is 22. Okay? So, since ginamit natin sa taas is yung h minus delta h over 2, let's try dito naman gamitin natin 30 plus 8 over 2. Okay? So, again, it will give you the same value dapat. Okay, ito, you can just input that here now. Tapos mu is given as well. So, you can do 0.5 na dito. Right? And that should give you the forging load that is necessary, no? Now, we can compute for the power. And if you look at the module, meron actually siyang ano, no? Formula for computing the power. And let me show you the formula. Ito siya. So, the formula for computing power is nandito. Where is it? This one. This is the formula for power now. So you might be wondering paano nakuha tong power nito. You can actually derive this, no? So hindi na pinakita sa module kung paano siya derive. Pero from ES, what is it? 101, I think. ES 101 power can be um sort of as torque times omega, no? So this is omega. Tama? So if you know the torque, so this is the power of a rotating object, no? So if you know the torque, if you multiply that by omega, then you get the power associated with that, no, with that operation. Okay? Pero this power right here is for one roll lang, no? Kasi 'di ba umiikot yung roll natin. Yun yung power associated with one roll. Pero in operation, ang minimum kasi is meron tayong two rolls, tama? So we actually multiply this by 2. So we have 2 tau, 2 torque times omega. Okay? Tapos to get torque, torque is just no, torque is torque T or tau ba yung ginagamit? I'm not quite sure, no. Maybe you'll have to review your notes. Hindi ko malala kung tau ba yung ginagamit na symbol for torque or capital T lang. But I think it's capital T lang. Okay? So let's just say capital T. So this is torque. Torque, if you want to measure the torque of a system, you'll just need the force multiplied by the moment arm, no? Okay? The moment arm. So for example, if this is kunwari ito yung isang um object moving in a rotational manner, so kunwari nagmo-move siya ng ganyan around this center point right here. Ito yung moment arm actually natin. Okay? This is the moment arm and this is kung meron siyang force na paganyan, then yung torque na na-experience niya is this force times the moment arm. Okay? And usually pag ganito, yung moment arm natin is equal to the distance multiplied by a correction factor, no? And I forgot the term for the correction factor. I think it was um arm factor, parang ganun. Parang ganun, no? Arm factor. So you can look up uh your notes and see kung ano talaga tawag dito, pero I think it's arm factor, no? So we get F times yung distance. So let's call this distance is, let's just say kasi this is the roll, this is actually the roll radius, no? So we do roll times gamma, times lambda, I mean. Okay? So the forging, so this force right here will actually be the forging or no, sorry, the rolling load. Okay? So the rolling load multiplied by the radius times the arm factor will give you the amount of torque. Okay? And if you multiply that by 2, then you get and multiply that by omega, you get the power. Okay? So this is, itong term na to, this term right here, ito times, so hiwalay natin to, no? 2 times 2. Okay? Tapos, this one, and uh, ayan, okay na yata. That will be the torque, no? Wait lang. No, sorry. For this particular case pala, because, sorry, it's not actually R, no? Kasi ang gagawin natin is, di ba, kunwari, if we look at the roll gap, no? And maybe I can show dito. Mas malinaw kung yung, ito illustration. So ito, the force is moving this way, no? So it's moving pag ganyan. And it undergoes, yung path niya will be itong from this point to this point right here. Okay? So ang torque natin will be the force times the distance, no? Tama? So this force right here multiplied by the distance na tinravel niya, which is the R delta H. Kasi this is the bite, no? So square root of R delta H, I mean. Okay? So yung torque natin, so mali pala to, sorry. This is wrong, no? So yung torque na makukuha natin is equal to force times R delta H multiplied by the arm factor gamma. So ito siya. So this one, this whole term right here, ito, times 2 will give you itong first term na to, no? The 2 torque. Now to get omega, omega is we call this as the angular velocity, no? This is angular velocity. And if you have the number of revolutions per second, let's call that as n, then if you multiply n by 2 pi, then you get the angular velocity. Okay? Tama. All right? So angular velocity in this case is measured in para naka-radians, ano, right? So obviously there will be different calculations pagka kunwari gusto nyo naka-degrees siya. Pero in this case, um yung number of revolutions multiplied by 2 pi will give you the angular velocity. And if you multiply that angular velocity, so that's in radians per second, multiply it by the torque, then you will get the final power requirement. Okay? So we end up with yung equation na to. So that is where the equation comes from now. Okay? So this equation. So yung 2 pi times yung original 2, kaya siya naging 4 na dito. And this moment arm right here is meron siyang fixed value, no? So it's usually from 0.3 to 0.5. Tapos ang ano natin is yung rule of thumb natin is for hot rolling operation it's 0.5. Pagka cold working operations 0.45 naman yung ginagamit natin. Okay? All right. So if you want SI units, dapat yung roll radius mo should be in meters, as well as the draft dapat naka-meters din. Tapos pagka yun yung ginawa nyo, ang if you want the final to be in megawatts, kung gusto yung megawatts, dapat meganewtons din yung ano dito. Pero pwede naman na naka-newtons siya. Ang lalabas dito is naka-watts din yung power. Pero if you usually we're dealing with large numbers, no? And the rolling load is usually expressed as meganewtons. So kung meganewtons to, this is meganewtons. This is in meganewtons to. And this is in revolutions per second. So unitless lang siya, no? So parang second -1 siya. So and ito unitless din to mga values na to. R delta H is in this becomes meter squared. So square root of meter squared is just meter as well. So ang lalabas dyan is meganewtons meter per second, and this is joule per second, and joule per second is equal to watts, no? So you get megawatts. If this is meganewtons, so this is megajoules, and therefore megawatts siya. Ganyan. So you need to be careful of the numbers, no, para um tama yung sagot na makukuha nyo. Right? So let's go back doon sa problem natin. We can use now the equation. So if ever you don't remember the power equation, then you can still derive it, no? Just remember na yung torque natin, yung torque times omega. Okay? So in this case, we have power is equal to the 4 pi times yung arm factor natin, which is this is a hot rolling operation, no? So kung hot rolling operation siya, yung arm factor natin will be 0.5, tama? It's 0.5 for hot working, tapos 0.45 naman for uh, cold working. Okay, so it's 0.5 and we multiply it by yung R delta square root of R delta H. So square root of R delta H is roll natin is 250. So that's 500 over 2. Tapos delta H natin is 22. And by the way, for this types of problems no class or si Lawrence lang naman dito. So for these types of problems, Lawrence, ang gagawin natin is mas no, it's always convenient to get the value of square root of R delta H na. So kung kumbaga i-multiply niyo siya para hindi na constantly pinapasok niyo siya dito sa no, ito 250 over 20, square root of 250 over 22. Kunin niyo yung value niya and lagyan niyo na lang siya na siya yung B. Tapos pwede niyo na input sa different kasi you'll be using this value a lot, no? Maraming times na ipapasok siya. So it's very convenient na i-solve nyo na siya. Right? So ito, tapos multiply natin by yung forging, yung whatever we got here. Forging, I keep saying forging, no? I mean rolling load. So rolling load. Tapos multiply that by the number of revolutions per second. Tama, per second. Pero dito roll speed niya is naka RPM, no? And usually yung mga din natin specifications for rolls usually naka per minute din talaga. So if you look at kunwari bibili kayo ng isang motor, parang it's expressed as RPMs, no? So kahit yung mga engines natin RPMs din 'yon. So you'll have to convert this first, no? So if it's RPM, if you want to convert it to revolutions per second, then you just, so this rev per minute, multiply lang natin by 1 minute over 60 seconds. So you get revolutions per second. So ito yung RPM natin is 40 over 60 gives us revolutions per second, and that should give you an answer in megawatts, no? Okay? So that's how you get the power. Tapos, you do the same steps naman, no? So, sa cold working operation. So, ang difference lang is, um, if, for example, ang nakuha nyo is, cannot be done in one pass, no? So, mangyayari, if it cannot be done in one pass, then you'll have to do two passes, no? So, you first do, kunwari, one pass muna, using the maximum. Tapos, yung remaining na, remaining na, kumbaga, yung kulang, kunwari lang ang lumabas dito is, let's just say 3, yung delta H max niya. Okay? So if 3 yung delta H max niya, and this is not the actual value, no, you'll have to compute. Kunwari lang, when you compute for mu squared R, ang lumabas is 3, which is, in our case, if you look at the, tingnan natin. Kailangan kasi na final thickness of 4, which has a delta H of from 8 kasi yun yung initial na natin, no? 8 minus 4 gives us a delta H of 4 millimeters, no? So in this particular case, kung 3 nga yung yung delta H max natin, therefore that is smaller than the 4 millimeters, tama? So it's smaller than the yung natin, yung required na delta H, then therefore hindi kaya na single pass siya. Kailangan mag two passes tayo. So what we can do is, yung first pass natin, we can do, so first pass natin was or first stand natin was, ito yung hot rolling, no? First stand, okay na tayo. So we started with 30, lumabas dito, naka 8 millimeters na siya. Okay? Now, ipapasok naman natin siya sa isang stand. Tapos ngayon, hindi kasi natin kaya na, no? So based dito, so kunwari lang, no? 3 millimeters, hindi kaya na ma-achieve na natin yung 4 millimeters natin dito. So, in that case, lagay tayo ng cold rolling, number 1. And it would produce, if 3 nga yung maximum niya, and then dito, magpuproduce siya ng 5 millimeters. Tama? Tapos, pasok natin sa isa pa na cold rolling. Cold rolling 2. And let's input lang natin. Delta H nito is 3 kunwari. And dito, delta H nito is kung ano na lang yung remaining na kailangan natin para ma-achieve yung final. And the final that is desired is 4 millimeters. So, we just do delta H is equal to 1 naman dito. Okay? Para 4 millimeters yung ano natin. Yung final ano. Okay? So, yun lang. Ulitin nyo lang yung process, no? Pero in this particular case, mukhang ang isa sa mahirap din is actually ito, no? Yung computing for the flow stress. Kasi unlike the hot working condition, binigay na kasi agad uh, yung flow stress. Pero dito sa cold working, parang sabi, kailangan daw gamitin natin yung Solomon equation, no? Alright, so if we want to solve for the for the for this one, kailangan natin i-solve muna yung y niya, no, or yung yield, yung flow stress niya as it passes through the different ano, no. Okay? Tapos kayo din pala magde-decide dito, kaso. So kunwari lang yung yung hindi kaya yung one pass, then you can decide na kung ano yung strategy, no. So ito kunwari ang ginawa dito is three two passes na three muna yung first, tapos yung second is one naman yung next pass niya is one yung draft. Pero ang more common na ginagawa is actually parang gusto natin na parang even siya. Okay? So pwede or hindi naman siya super common, no? Pero parang mas convenient siya i-calculate kung even na lang yung gagawin niyo. Okay? So but again, it depends on your strategy, no? When you go into the industry, siguro magma-matter na rin yung kumbaga kung ano yung available equipment, kung yung mga economics of buying mga ganitong stands, etc. etc. no. So ito, pwede naman ang gawin nyo instead of doing delta H 3, delta H1, alternative solution will be ito delta H2 tapos dito din delta H equals 2 din. That will also work, no? So, ang mangyayari dito is 8. It comes in 8. Lalabas siya na 6. Delta H of 2 again. Lalabas dito is 4 ulit siya. Pwede din to. This is also an alternative solution. This will also work. Alright? So it all depends kung ano yung delta H max natin. Kasi kumbaga, itong delta H max na to is also appropriate dito, no? Tama? Kasi we are doing 2. Um, another scenario is, let's just imagine na, what if one lang ang ano, no, ang delta H max. If one lang ang delta H max, so tingin mo Lawrence, kung one yung delta H max, ilan yung kailangan natin na rolls or stands?
If 22 po yung, ano sir, yung delta H po. Ay, yung draft po. Tama po ba?
Kung
Ay,
kunwari nandito na tayo sa 8. Kunwari 8 tayo, no? Tapos ang sa
opo.
cold working operation, so tapos na tayo sa HR, sa hot working.
Ah,
So kunwari lang yung delta H max natin is only 1 millimeter. Or para mas interesting, no, let's do 1.2 millimeters. Tingin mo kung ganyan, ilang stands yung kailangan, yung necessary para ma-achieve mo yung final na dimension of 4 millimeters?
mga 7 po sir. Parang ano.
7?
Wait lang.
Nag-start ka na with 8, ha? 8 na. Kasi di ba 8 na kasi siya. So kailangan mo na lang gawin siyang 4.
Okay po. Tapos sir, 1 millimeter po yung
Oo,
max
yun yung
niya.
maximum lang. Hindi, based sa calculation. Kunwari lang yung mu squared r na lumabas is 1 lang. Or 1.2, kunwari.
Magpo-4 na lang rin po.
Tama, no? So magpo-4 ka. So parang ang gagawin is parang delta H equals 1, delta H equals 1, so on and so on. Tama, no? So yun, yun yung mga considerations, no, when we solve these types of problem. Titingnan nyo yung delta H max because the same delta, yung delta H max na to will be applied to all operations, no? So, kunwari ito, CR1, delta H max, kunwari yung first natin na nakuha is 3, kunwari. So, delta H max dito cannot exceed 3. So, ito naman, pasok naman siya. Ito rin cannot exceed 3, which is 1 din naman. Dito rin, cannot exceed 3, 2. Ito, cannot exceed 3, 2. So, pwede din naman siya. So, yun. So, the number of stands will depend on kung ano yung delta H max na may establish for the operation. So, may tanong ka pala dito, Lawrence, no? Posible po ba na mas mababa po yung power consumption if ginawang two stages po yung rolling as compared po sa hot rolling lang? And if possible, minimum stand pa rin po yung kukunin. I think posible yon. So, actually, isa to sa, ano no, at the end of the parang yung sa dulo na you'll actually be given a design problem, no? So isa yan sa mga parang kailangan yung i-consider. Pero dito for this particular problem, ang sabi lang kasi is minimum stands lang, no? So for this problem, aim natin is to have the minimum number of stands possible. Pero kung kunwari na ang sa design problem kasi it's optimize the process, no? So meaning you get the maximum profit, and therefore part na sa consideration natin is yung power consumption. So pagka ganun sa those types of problem, and may experience din talaga to in this course to, yung design problems. Kailangan nyo i-consider na yung power consumption. Tapos tingnan nyo kung nag 3 stands kayo, ano yung power consumption. Pagka 2 stands, ano yung power consumption. And you'll do parang comparisons. No? And based on the comparisons you made, you'll be um, kumbaga dun yung magde-depend yung selection process, no. Okay? So doon naman sa design problems, we will have consultation sessions naman. So para matulungan ko kayo kung ano yung yung flow ng ano niyo, no, yung design niyo doon sa solution niyo, right? So nasaan na ba tayo? Hope that answers your question, Lawrence.
Yes po. Thank you, sir.
Okay. Pero that's very interesting, no, na naisip mo na as early as now yun. Okay. Nasaan na tayo? So, gagawin natin is no, yung mahirap lang dito sa part na to is actually computing for yung gagamitin natin yung Holomon equation, no? And if you remember the Holomon equation, you'll have something like ano ba yung Holomon equation? Holomon is K sigma n is equal to um ano ganun, no? D sigma. Wait lang. I'm trying to remember now if this is wait. It's something like this, no? Tama? Right. Okay, so para magamit natin to, you can actually look back at the, I don't know. Let's look at the module and I'm trying to find it, yung equation natin. Holomon. Saglit lang, Lawrence, ah. Okay. So if we want to get the rolling pressure, ang gagawin natin is we need to find the true the true strain value, no? Kasi if we want to use the Holomon equation, ito siya. If you want to use this one, ito dapat naka-true strain value to. Tama? So, um, kailangan ko i-drawing, no? So, for example, if this is your roll, tapos, nandito siya. Pangit yung drawing ko, no? Pero, let's just imagine, sige, half lang ng roll yung drawing ko na lang. Para mas malinaw. This is half a roll. And if etong first entry point na to, this is where you begin to, ano no, you experience the, baga yung compressive forces. So dito, initially, nagsistrain yung material natin. Okay? So this is the initial flow stress, kumbaga. Pero notice how, as you go along this path, no, you actually experience strain hardening. Tama? You harden as you go from point, let's call this point A, hanggang sa point B, hanggang mag-exit ka pa ganyan. You you have a strain hardening effect. Therefore, yung yield stress needed to, or yung yield stress that is required to deform your material at point A is not the same as the yield stress that is required to deform the material at point B. Tama? And with that, when we're computing for the average rolling load, no? When we are computing for the average rolling load, ang ginagamit kasi natin is yung average flow stress. Tama, no? But in this case, wala kasi tayong one value lang. Kasi may value tayo dito at may value din tayo dito. Tama? Yung initial, pwede natin kunin from the, ano, no? Ah, saan ba? Nandito. So from the yield state daw kasi, yung yield strength natin is 300 megapascals. Right? So kung 300 megapascals, we can say na 300 megapascals yung initial na needed na force dito. Now once it arrives at the final na end of the I don't know. So this is similar to the forging forging problem wherein 'di ba may kunwari sa forging, iba yung flow stress needed at the start of the stroke versus pagka yung tinatawag na end ng stroke. Tama? Pagka nag-end na yung stroke natin, yung nandito na siya, bumaba na. Iba na to kasi nag-strain harden yung material natin. Parang ganun din dito, no? This is parang quote-unquote the start of the stroke. This is the end of the stroke. Okay? So this is the starting yield strength. This is the ending yield strength. So if you want to get an average, kasi again, when we're computing for the average forging load, we use average pressures, no? So we need to compute for yung requirement at B, no? So kumbaga hanapin natin yung parang Y at this point B. Or we can call it as Y at the end, no? So this is the Y at the start, or YA. So if we get the average YA plus YB over 2, then we get the average na forging, the average rolling load for cold working conditions. So ang needed na lang natin is etong gagamitin natin si Holloman for finding YB. So YA is already known, 300 siya. Now we need to find YB. Now to solve for it, we go YB is equal to K is given, no? Ano yung K natin? 1426. So that's 1426 times epsilon multiplied by a raised to the power of 0.5. So that's N. Now, how do you find epsilon? Kayo na bahala mag-solve nito, no? So you need to take into account that this is true strain. Pero I think the engineering strain is also acceptable, no? Pero if you want to be accurate, yung true dapat yung gagamitin natin. So ito, you already know the delta H values. Kung alam niyo yung delta H, then you can know kung ano yung amount of strain na na-experience ng material natin. So that's why it's also convenient to na ang gamitin natin, hindi rin pala. So I'm thinking is mas simplify ba if you have the same delta H values dito. So, isa yan sa, ano no, kailangan nyo i-consider. If you do the same delta H, would you have the same epsilon? Kasi kumbaga, same lang ba yung A to B nyo? As opposed to different delta H's, no? Like, for example, in this equation, delta H is equal to 3. Definitely, iba yung amount of straining dito versus amount of straining dito, no? So, yun, isa yun sa mga considerations, no? Pero if you don't mind computing twice for YB, then okay lang naman. Okay? So, again, hindi ko na ipapakita kung paano nyo i-solve to. You'll have to do this on your own, no? Pero with that, I think that's the only hard part about this problem, no? Is that yung sa cold straining part, kailangan natin is hanapin pa yung average na flow stress. Okay, hindi siya straightforward na binigay. Unlike the hot working condition, which is binigay na agad diretso na ang average flow stress is 200. Okay? So, kung solve nyo na yung YB, pwede nyo nang i-input sa forging, sorry, why do I keep saying forging, no? The rolling load formula, which is this one, pasok nyo lang dyan. Tapos, pag pinasok nyo na siya, you can also find the power requirements na din, no? Right? Tapos, pagka may dinagdag ba? Feeding material entry, given that, find total power requirement. Okay, so total power requirement, ang gagawin nyo na lang is, you get the power requirement here. So kung ano yung megawatts dito, you get the megawatts din dito and get megawatts dito. You add it all up, yun yung total power requirement. Okay, so I think si problem 3, I think you can do that on your own na. May problem 3 pa ba? Wala na ata. Two problems. It's two problems lang pala. Okay, so hopefully nakatulong to, no? May questions ka ba, Lawrence? Or was this
Ay,
session helpful naman?
yes po. Sir, ano sa problem 1 lang po, sir. Yung
Sige.
sa ano po, sa mga sa lubricants po and yung sa friction values po nila. Sir, ano pong ibig sabihin? Like, yun po
No,
ba yung nung sa lubricant po and friction value? Yan, sir. Ano po
dito,
yung
dito.
ibig sabihin? Yes, sir. Like, yung po yung kaya nilang i-handle na friction or what?
Yung kumbaga yung lubricant can provide mu value equal to this range. So 0.12 to 0.16. Tapos si lubricant B naman, yung mu na mapoprovide niya is 0.17 to 0.21.
Okay. Sir, kunwari po, sir, yung nakakuwang user 0.20, sir. Ganun, sir. So, pipilit po ba lubricant ng sir B and C since mas or yung B lang, sir?
Ah, kung ano yung nakuha, 0.20?
Opo. If kunwari po, sir, is 0.20.
Kunwari, ito yung nakuha mo. Hindi, B
Opo.
yung pipiliin mo kasi pasok siya sa range na to eh. Si C kasi is 0.22 to 0.26.
Okay. So, kung ano po talaga yung nakapasok.
Ah, ah. So, kumbaga, kasi yung requirement mo, kung kumbaga, ang lubricant requirement mo is that it can provide mu equals 0.2, then therefore, si lubricant B yung appropriate na gagamitin mo because it can provide that range, no? So from 0.17 to 0.21 kasi yung napoprovide niya.
Okay.
Tapos walang overlapping kasi dito eh. Kunwari ito, 0.16. So, design tong question na to na naka-cut off siya, no? So, from 0.16, tapos ito 0.17 to 0.21. Ito naman, 0.22 naman, cut off niya to 0.26.
Okay po. Sir, pwede mag-ask din po sa forging.
Sa, ano to, Lawrence?
Sa forging po, okay lang po.
Sige, okay lang. Go ahead.
Ano, sir,
Ah,
pag sinabi po na, ano, sir, minimum forging load required to initiate the forging process, sir. Yun po ba yung, ano, sir, considering na maka-forge yung lahat ng element or